6.2 Bisectors of triangles. Essential question: can I find the circumcenter of a triangle? Can I find the incenter of a triangle? Let's take a look at this word concurrent. When lines, rays, or segments meet, we call this a point of concurrency, especially when it's 3 or more lines. In this particular picture, we're going to have 3 perpendicular bisectors. You can see they're in blue. Right here, here's our construction. And when all of these lines meet at one point, that's called a point of concurrency. This particular point is called the circumcenter. It's called the circumcenter because it's the point of concurrency for the 3 perpendicular bisectors. The circumcenter theorem. The circumcenter theorem says that the circumcenter, remember that's the point which is created by all the perpendicular bisectors. So here's a perpendicular bisector, here's a perpendicular bisector, and here's a perpendicular bisector. So it says that the circumcenter is equidistant from the vertices of the triangle. So the conclusion says that this particular point, this distance, and this distance will be all the same. Now, why is that true? Let's take a look at the theorem. Here at the heart of the theorem is the perpendicular bisectors, and here they all are. And they're all going to meet here at point P, and point P is located right here. Now, once you find them, then we know that the perpendicular bisector theorem says that this is going to be equidistant. So we know this distance right here will be equal to this distance right here. Since this is also on the perpendicular bisector for this distance and this distance are the same. So we know this distance and this distance are the same. And that's true for these two as well. So we end up getting all the distances the same to these vertices. And that's what the circumcenter theorem is stating. Let's take a look at a picture and see how we use the circumcenter theorem. We have 3 carts, and we want to find where the frozen yogurt distributor ought to be so that it can have the same distance to each one of the carts. And we're going to use the circumcenter. Remember, the circumcenter is formed by perpendicular bisectors. So I'm going to try to find the midpoint, and then I'm going to try to draw a perpendicular. I'm going to try to find a midpoint, and then I'm going to draw a perpendicular. I only have to do it for 2 because I'm going to create the point, and 2 lines will intersect at a point. I don't need to do the 3rd one. Now let me show you on the next diagram where I've drawn it a lot better. So you can see I've drawn the perpendicular bisectors. They meet at point P, and now the circumcenter theorem says that from P to this vertex, P to this vertex, and P to this vertex, all of these distances are going to be the same. And that's what the circumcenter theorem states. Okay, your turn. This time it is going to be 3 snack carts, and we want to find the location where the pretzel distributor can be equidistant to all 3 carts. Stop the screencast and see if you can locate it. And here's the answer. We're going to create the 2 perpendicular bisectors for 2 sides of the triangle. Where they meet is what we call P. And this point P will now be equidistant to each one of the corners. Okay, let's do it in the coordinate axis. Well, now we have a triangle, and our triangle right here is A, B, C. So think about it like this. We have a triangle right here, A, B, C, and we want to find the circumcenter, which requires that I find the perpendicular bisector. So I'm going to try to find the midpoint, and then I'm going to draw the perpendicular. Now, it looks like I want to find the midpoint between A and B, and I want to find the halfway distance, which this looks like the halfway distance. And then I want to draw this line. So this red line is this perpendicular bisector. Now I'm going to use BC. I'm going to try to find the middle right here. and then I'm going to try to draw the perpendicular. Now the middle right here, this is 1, 2, 3, and then on the other side is 1, 2, 3. So this is the middle, and then I try to draw the perpendicular. Now where they meet is what we call the circumcenter, and in this case this is the answer, 3, 1. Okay, your turn. Go ahead and try to draw the perpendicular bisectors for two sides. And I suggest it's the horizontal side and the vertical side. Take a minute to do that and see if you can find the circumcenter. Here's the answer. Okay, let's try it one more time. Here's the triangle. See if you can find the circumcenter. I strongly suggest you find the perpendicular bisector for the horizontal side. Find the perpendicular bisector for the vertical side. Stop the screencast and see if you can find it. And here's the answer. Okay, when we talk about a circumcenter, I want you to know that the circumcenter can occur inside the triangle when it's a acute triangle. It will occur on the triangle when it's a right triangle. And it will occur outside the triangle when it's an obtuse triangle. Now let's talk about why it's called a circumcenter. Now I want you to notice that, remember, this point is equidistant to all the vertices. And when that happens, it reminds me of the radii of a circle, and see how the circle is going around the triangle. All right, let's do it again. Here is the circumcenter. It is equidistant to all the vertices, which reminds me of radii of a circle, and you can see the circle going around the triangle. And then here again, here's the circumcenter. It is equidistant to all of the vertices, which reminds me radii of a circle, so we can draw the circle. So maybe you can see why we call it a circumcenter. Center meaning center of a circle. Circum, like circumscribe or circumference, going around the triangle. All right, now let's talk about the incenter of a triangle. Incenter is formed by the angle bisectors, 3 angle bisectors. So you can see with these constructions, all of these are angle bisectors, and they all meet at a point. We call this point the incenter. We have the incenter theorem. The incenter theorem says that the incenter, so this point, which is created by all these angle bisectors, all of these are angle bisectors, once it meets, then it is equidistant not to the corners or to the vertices of the triangle, but to the sides. So all of these distances are going to be congruent. All right, let's take a look at a problem, and I'll go ahead and work with you on this one. I want you to notice that N is an incenter. Now, how do I know it's an incenter? Okay, I notice it because right here I have an angle bisector, and right here I have an angle bisector. That's the big giveaway. Incenters are created by angle bisectors. Now, once we find the incenter, we know it's equidistant to the sides. So that means this side, NE, and ND, and NF are all the same. So I'm going to write ND equal to NE, and I could even say it's equal to NF. And I'm going to set these two quantities equal to each other. 5x minus 1 is equal to 2x plus 11. So I get 3x is equal to 12, x is equal to 4. Now I'm going to want to find ND. ND is 5 times 4 minus 1, which is 19. So all of these are equal to 19. Can NG be equal to 18? Remember, we just figured out that this was 19. So can this length right here, that's what they're asking us right here, can this length, question mark, can that be 18? And the answer is no. This is the shortest distance. This distance will be longer. You can even see it looks like a hypotenuse of a right triangle. All right, let's take a look at this. Now again, I see an angle bisector and I see an angle bisector. Angle bisectors create an incenter. An incenter is equidistant to all the sides. So all these distances are the same. So I know that QM is equal to QN, which is also equal to QP. So I can say 3x plus 8 is equal to 7x plus 2. So 6 is equal to 4x, and x will be equal to 3 halves, or you can say 1.5. Now I want to find QP, which I'm going to just say QM is equal to 3 times 3 halves plus 8. So that's going to be 9 halves plus 8, which is 4.5 plus 8, which equals 12.5. So that means all of these are going to be 12.5. All right, let's take a look at this situation. We want to put a lamp post so that the lamp post is the same distance from all 3 streets. All 3 streets. Not the 3 corners, but the 3 streets. So we want to find where to put the lamp post so that the distance to this side street, and this street are all going to be the same. So will it be the circumcenter or will it be the incenter? Remember, the circumcenter is equidistant to the vertices, and incenter is equidistant to the sides. So the answer is I'm going to want to find the incenter, which means I'm going to want to do angle bisectors. I want to find where those angle bisectors meet, and where they meet, wherever it is, that point is going to be equidistant to all the sides, and that's what I want. Okay, let's stop the screencast, see if you can fill in these words, and you can check your work. And here are the answers. The circumcenter is equidistant to the vertices of a triangle. The incenter is equidistant to the sides of a triangle. And point I is what we call the incenter. Remember, it is equidistant to all the sides. And whenever something is equidistant to all the sides, it's like radii of a circle, and that means the circle is inside. So incenter standing for inside circle. And this will be the circumcenter because it's created by the perpendicular bisectors. So circum means going around. You can think of it as the outside circle. And this is the end of the screencast.